Hello, my name is Juan Vargas, and this is my final presentation, chapter 7 through 16. And let's get with it. What I learned in chapter 7 was about windows and doors and how they represent an important part in marketing decisions for builders and also design tool for architects. And how windows have a big impact on energy efficiency for green building, and they are ranked second to the design of an HVAC system in overall technology complexity. Double glazed windows, often called sealed insulated glass, separates two panes of glass with an air space for better energy efficiency. Doors come in almost any size, style you can think of, and materials. Fiberglass, wood composites, vinyl, and metal. In case of interior doors, weather thickness, insulating valve, and installation are additional considerations. Insulated fiberglass or steel entry doors several times are more energy efficient than a solid wood door. For example, fiberglass is more impact resistant and likely to show dings and dents and conduct less heat than a metal skin door. Chapter 8 discussed about plumbing and how we can create a plumbing system that meets green building requirements. And I also learned that heating up water for domestic use accounts for much as 30% of residential energy consumption. Or, for example, water heaters themselves can add up to sustainable savings in energy using over the life of the appliance. And having clean water is becoming a real critical issue for the planet only because 1% of the water in the planet is drinkable and much of the rest is polluted. Reducing the flow of water makes the system less efficient because a volume of water means longer waiting time for heat and water. More energy losses, which means more wasted water. Chapter 9 discusses about heating, ventilation, and air conditioning. How HVAC equipment should be designed specifically to meet reduced loads, but never designed by conventional. Radiant floor heating systems that use cross-linked tubing to distribute hot water have some advantages over forced air systems, but these can typically cost much higher. It's not particularly to add air conditioning. Water for radiant floor heating system is typically heated by a boiler, but passive solar design and energy saving building techniques may allow the use of conventional water heater, much less expensive option for the heating system. Chapter 10 discusses about electrical systems. Electrical generation consumes enormous amounts of fossil fuels. The nation's electricity is delivered over a grid of power transmission lines that allow utilities to move power where and when it's needed. There is a big problem with light bulbs. They're so wasteful of energy that a number of efforts are being made to ban them worldwide. A variety of alternatives use less power and last longer. Solar outdoor lighting can save money both on installation and on the electric bill, although batteries and light bulbs will be probably changed occasionally. Solar cells last indefinitely, like cheap plastic models will self-destruct after a couple of years of service. Their light bulbs will have short lives, which are worth paying more for higher quality fixtures. In chapter 11, it discusses about installation. Installation is a thermal barrier of the house. This is the pathway where heat can be lost. When it comes to thermal conservation, if a house is poorly insulated, there will always be an energy wastage. If the material is used, the type of material used in insulation does not allow airflow, the air inside the home can become unhealthy, and the different types of installations is fiberglass bats, non-fiberglass bats, wool, cotton bats, loose fill insulation, spray-in insulation, and red foam. Chapter 12 discusses about siding and decking, and how siding is mainly for aesthetic purposes. Siding is meant to protect the weatherproofing of the home, so the moisture doesn't get stuck between the siding and also the outside of the structure. And for the decking, you want to make sure it doesn't impose problems to the structure, making sure the material used is sustainable to the structure itself, so it won't create any water leaks and any toxic, hazardous parts to the structure itself. Chapter 13 was about solar energy and how it's a good choice to save and reduce energy costs. A basic solar system for producing hot water has a very low cost when installation is added into the mortgage. That can be a rapid representative of saving in energy costs, such as passive solar designs, cover site solar orientation, room layout, material selection, all which can reduce heating and cooling costs. Solar panels come in a number of different styles and price range. Homeowners should always consider solar systems even if they are trying to find other ways to reduce energy loads in their home. Chapter 14 was about indoor and air quality. In the chapter, I learned that indoor quality and maintaining high indoor air quality is very important for a component of green building, because as the home gets tighter, there is more likely possibility that chemicals would be trapped in the air that we breathe. Strategies that can improve the air quality you can use: mechanical ventilation and air infiltration. You can also include a different type of barrier that can protect from hazardous things like radon gas, mold spores, and other contaminants. Chapter 15 talked about interior finishes. Like when selecting materials, it's very important to choose those that are very eco-friendly or recycled materials. Low VOC paints, all natural materials like concrete, wood, and stone, or like concrete is used as a finished floor, can reduce the amount of material used in the interior of the home. Or for example, drywall made from recycled material is denser and stronger than the standard version. Green floor is durable and also non-toxic. Renewable sources, something you might want to consider when using radiant floor heat. Chapter 16 discussed about landscaping. When considering going green in landscaping, you should think of the grass that could be a major contributor to the water and air pollution that can consume over thousands of gallons of water each year. You should also have in consideration the type of soil that the home has in its premises and the type of weather you have all the year round. For example, having the right type of plants, trees, and grass in around the area of the home, cooling and heating should be better for the HVAC system. Will not be one of all the time making and consume less energy. So this was my final presentation for chapters 7 through 16 for class CMT 161, and thanks for watching.